Hey there, buddy. I want to talk to you about my new project. Well, past last summer, I thought to myself, what better way to bring the joy of my code to the masses? And the only way they appreciate it, at the end of a cold metal hand of a death machine I created. Wasn't quite sure where to start, had a bunch of ideas, had a bunch of keywords, so I binged the living hell out of these things. Found a bunch of amazing stuff, boards and circuits and Wi-Fi and RFID tags, but nothing quite seemed to fit together in a way that made sense to me. I wasn't sure where we spent my money at. Is it well spent? Not well spent? So I was feeling a little discouraged. Figured need to get a kit. Kits are always good. And it struck me. Back in college, I had a computer engineering friend and more of an associate that just loved circuitry. This kid would go nuts on it. He was constantly putting these stamp circuit boards together and having it light up and open gates and do all this stuff, and he just loved it. Didn't necessarily like that into code, but who does? Well, I figured what was good in college definitely be good in adult life. So I went off and found me this Boe-bot kit. Guess these are things they hand out to college kids and students. So, and high school students. The company who makes this thing is called Parallax. They still exist. They're still around. Shocking enough to me. And you can get one of these kits for about $160 online. Now, there's a couple kits you can get online for a little cheaper, but they're like the serial ones. Really, who has actual serial port anymore? I sure as hell don't. So I went for the USB option. Now, let's see what's actually in this kit. Kind of figure out if this is something you would want to do, something you want to get into, and you're not sure what you're getting. Let's kind of give you the basics. That stuff I didn't have when I was doing this. So here we have the joyous little box. A little views and a little use. Bottom panel shows you some nice things you can do with the kits. Some spiders, some tracks. Side kind of breaks apart the board. And here we have nice pictures of NASA, because that's what you do when you have robots. On the back, the general stuff that goes on there. Open this sucker up and see what we got inside. Well, it's a nice, handy dandy little white box. Open this thing up, the first thing you'll probably find in your box is paperwork. Here we have a nice piece of purple paper. That is a toll-free number, tech support, and warranty information. On the back, little warnings about some capacitors and the safety with them. Apparently, you discharge these things wrong, they can kill you. Moving on, we have more paperwork. Nice rust stain on the top, but that's probably from the company that got this from. Paperwork, outlining the nature of the circuits, use of the breadboards, stuff I haven't actually read through. I think that's a circuit diagram of everything on the board. Didn't care. Then they give you a copy of the software. Now the software is from September 2006, so I opted to go online and find the better updated version. Haven't touched it since. Then we find the giant book. And this apparently was probably what your textbook would be for your class. Go inside, it's black and white, big thick spiral, and walks you through all these exercises, all these different options to add sensors, add motors, add rotary tools. I don't think we're adding that yet. And also the subsequent code that goes with it. Does a pretty good job explaining that. And so far I'm about a third of the way through the book. Pretty cool. Let's see, random bag of stuff we have. A shield for this. Here have been the container that the Boe-bot board came in. Metallic, not quite see-through. Pretty good, but now empty. Here would be the bag the chip came in. You would slap this chip in the board and pretty much don't touch it after that. I guess there was some sort of, kit or developer board. You could pop the chip out, put it in, use it that way. So far I haven't need to. Once I started assembling things, everything went in there together. As this is the USB version, you get a pretty lengthy chunk of micro USB cord. Plugs into your board, and you can write code directly to it. Lovely bag that this thing came with. And a little bag of parts that were left over, extra rubber bands, some bits that came with the servos. Took them off when I didn't need them anymore. The lovely Boe-bot tool. Flat head on one end, Phillips on the other. A little pin thing in case you want to carry this around in your lab coat. Look pretty cool. So far I've been pretty handy with adding the servos to it, but not a whole lot after that. Then we find the bag of bits. As you can see, this is a nice anti-static bag. Oh, FY, don't lose these bits. My exuberance opened this bag, and they went everywhere. It took me about 2 days to find all my bits and pieces. In here, you'll find cacophony of little things. Some sort of push wires and sensors, tons of little wiring, some of it already open, cut to appropriate lengths, resistors. I have no idea what this is, some sort of sensor. Side note, engineering students, if you can read these resistor numbers on here, God bless you for it. They're a pain in the ass to find out, trying to figure out in natural light what that color was. Pieces of candy, looks like, some infrared LEDs, and all sorts of cool stuff. The question at this point is, where the hell's the robot at? You know, it didn't look like anything in the package was there. That's because I've been already somewhat assembling this thing. Here it is. This would be a couple of lessons into assembling the chassis. For a while, they have you working with the board itself, you know, plugging it in, showing how to write the code, having LEDs blink. I went in and decided to finally get this thing moving. Figured, what good's a robot if it can't move around to do my bidding? Now, you're probably wondering, how big is this bastard? Well, about the size of a can of Mountain Dew. So, not the most amazingly large thing, but big enough to work with, even with these large mitts, and good enough to definitely practice what I'm doing. Let's take a look at what we have here. So, on our kit, we have, this is the chip I was talking about. That's in a little bag. Pop it in, don't remove it again. Your USB plug over here, your various modes of off, debug, and on. Nice reset button. Your breadboard where you'll plug into all of your resistors and sensors. Right now we have a little piezo speaker that makes a noise. To the red LEDs, a flash when I feel like it. And a couple of resistors jumping from the power connectors here to the spot in the breadboard, and then that also terminates in the ground. Up here we have my two lovely wires that go to my servos hooked in. I'm not sure what the hell this thing is for. Power right here. Now this thing also takes 9-volt batteries. You can have one sticking out here. I ended up just going for a couple 4 AA's. FY batteries are not included. Look at the side. Here's a wheel. Kind of see the board underneath it. For a while they had these little rubber stamps. I was holding it off the ground while I was doing some initial work with it, which I presume this would be the front end of it, because I'll have some sensors coming off here, the side, and the back with a little caster bottle. Now, under all of this is where the 2 servos are at, here and here. Here's also the battery compartment that you should probably pop these batteries out when you're not using them. So overall, pretty nifty little device. Pretty hefty, pretty sturdy. Now the code writing for this thing is pretty simplistic as well too. It's a variant of BASIC, and you just type these commands out. Not a whole lot in there. Does some auto-correcting for you. But, you know, it does what it does. And, you know, you can make it frequency options to push out sounds to speakers. You can then also have it tell the for loop how far you want to move the wheels and which direction to move them, how fast, how little, how slow. You make the LEDs blink in funny fashions. And eventually you'll be able to get force feedback from sensors in our Boe-bot parts that the program will be able to react to. Now, with these kits, this is something I didn't know, is once you write a program and send it to the Boe-bot, it's on that chip until you overwrite it. So anytime you power it back on, it will run the last program you had. Let's see what I had on there last. Ooh, annoying noise. Oop, back, turn, reverse. Ah, so I must have been trying to calibrate some of the wheel functions. Awesome. Let's try that again with the reset button. Pretty slick little thing overall. I enjoy it quite a bit. I'll have plenty of time to go through the 40 different exercise and options this thing goes through, and definitely getting a better grasp of what I want to do. From here, I'm looking at going and branching out with FES 2 Panda boards. Those particular boards are much like an Arduino board, but they work on the .NET micro framework. Something I'm more familiar with, something I enjoy. Why not go for that a board like that? And it's a little heftier, a little beefier than your actual average Arduino board, and they sort of work with a lot of those same clip-ons and shields that it has. There's a company called GHI that makes these boards, and they're amazing from what I can read and understand on YouTube. And they also make this thing called Internet of Many Things, where you have a shield that comes with it, and you essentially make your own web server. You know, clip this thing together, and boom, you're off and going. How awesome is that? There, I'm looking at possibly going into the LilyPad. They're Arduino based, yeah, not my favorite, but it happens. But they're wearable circuit boards with things like wire, well, not necessarily wire, but yeah, essentially a wire that's a thread. And it's a little silver thread you can weave into your clothes, and this board's apparently washable. And you can have your clothes light up and write code for it. Say you want to have a GPS sensor or a compass in there and lights up in which direction you want to go to. That's all possible. Sounds pretty fun. But as we start with ground one. Now, I think that's pretty much about it. So I'll keep you posted in terms of how this goes and what I need to do. If you have any questions, shoot me an email, shoot me a PM. Definitely funding questions you have if you're looking at possibly buying this kit. If you don't want to, that's fine. I'm not going to hurt my feelings. But if you need to figure out if this is good for you, let me know. Talk to you later. Bye-bye.